Apologies for all the background noise in the last video. There was some folks moving chairs next door, so I decided to switch rooms, and hopefully this room will be quieter. All right, so last time we made the interesting discovery that the dot product of A and B, you can compute it. It's equal to the length of A times length of B times cosine of theta, where theta is the angle between A and B. And furthermore, as long as A and B are not 0, you can actually solve for theta, and you can get theta equals inverse cosine of what? A dot B over length A, length B. All right, so I wanted to just talk through a couple of things with you. First off, this formula is not as convenient as the first formula that we learned for A dot B. That's your go-to formula if you have A and B in component form, but you might not always. There's situations where you know the angle between them and you know the length of A and B. Well, then in that case, it's not hard to compute A dot B. So you might deal with some of that on the homework. I also want to mention that this part here, solving for theta, I am assuming both A and B are not 0. I think I said that, but I'll say it again because I'm dividing by length A, length B. So I want to avoid division by 0. That's never a good thing to do. All right, so let's go to another definition. So we're going to call two non-zero vectors orthogonal if the angle between them is, let's move that down a little bit. Oops, the angle between them is pi halves. So you should think of orthogonal, perpendicular, same thing. Mathematicians like to sort of generalize ideas from geometry. So we sort of think of perpendicular as a geometry type thing, whereas orthogonal, you can use that same word in any space where you have an inner product. So the dot product is I'll stop. But the point is, orthogonal for us simply means that the angle between the vectors is pi halves. And so we're going to denote this by, well, we're going to say A and then perpendicular, orthogonal, whatever, that symbol B. Okay, and this is an important detail. I want to point out to you that 0 is considered orthogonal to all vectors. Now, in the last video, I asked the question, what good is the dot product? What good is this new formula that we came up with? It's all fine and dandy that the dot product is actually length A, length B, cosine theta, but what good is that? Well, I think one of the most useful aspects of the dot product is the following fact, and that is simply this. The dot product between two vectors is 0 if and only if the vectors are orthogonal. I'm not going to quote-unquote prove this for you, but I do want to look at why it's true. And so it follows from the formula that we just learned. A dot B is length A, length B, cosine theta. So let's assume that the dot product is 0. If it's 0, and then, if either A or B is 0, then we consider 0 orthogonal to all vectors. So what that means is we can sort of assume that A and B are both not 0. If they are, this is all trivial. So I'm assuming A is not the 0 vector, B is not the 0 vector, and if their dot product is 0, and that's not 0, and that's not 0, then cosine theta has to be 0. And if cosine theta is 0, well, it's not too hard to argue that theta needs to be pi halves. Now, you could say plus or minus pi halves, whatever. The point is, it doesn't matter which way, the angle between A and B has to be 90-degree angle. So I'm just going to say theta is pi halves. Vice versa, if the angle between A and B is 90 degrees, is pi halves, then you automatically know cosine theta is 0, and so A dot B is 0. So that's a brief explanation of why this fact is true, but you'll want to know this fact. This is really a useful tool. Just compute the dot product. You compute the dot product typically with the easy algebraic formula, although of course you can use the other formula too. And if you get out 0, then you know the vectors are orthogonal. And if you don't get 0, they're not orthogonal. I'm not going to go too crazy on this, but you can sort of see that when the angle between A and B is less than 90 degrees, i.e. when you have an acute angle, then the dot product is going to be positive. When the angle between A and B is more than 90 degrees, i.e. you have an obtuse angle, then the dot product is going to be negative, because cosine of a angle larger than 90 is going to be negative. Cosine of an angle less than 90 is going to be positive. So the sign that you get, if you get out A dot B equals 3, if that's something that you somehow compute and you know that it's 3, well, now you know that, I can't tell you too much, but I can tell you that the angle between A and B is actually acute. So that's some geometric facts for the dot product. And I think we'll break this video here, and then we're going to end this lecture with vector projections.